One-piece flow is probably the most important thing that you could do to open up all kinds of possibilities in your company. When you really understand it, internalize it, and get it down. Today, we're going to be going to Seating Matters, one of the best companies in the world, and we're going to see if we can make their one-piece flow even better. By the way, if you're new to the channel, my name is Hugh. I teach business owners how to optimize their operations. It's the one thing that can take a business from 0 to 1 and sustain it indefinitely. Background was manufacturing. I help all kinds of businesses. If you are new, I am a huge proponent of the lean method. I applied it to my own businesses, retired a millionaire in under 2 years, and now I just help all of my friends do the same. So let's get into one-piece flow, the one thing that will change your business forever. Let's get into it. By the way, Ryan and his team were so grateful and generous in letting us go visit. You should definitely go visit Ireland if you get the chance. Seating Matters is one of the most incredible companies ever, and I'm happy that I can give back in some way. Go check out Ryan's YouTube channel, Lean Made Simple, and here is the secret to one-piece flow.
Today we're just going to be experimenting. You guys are messing with the wood line, right?
Yeah.
So everyone loves U-shaped cells. I was just going to point some stuff out where we can kind of practice with these trolleys real quick. Having a bunch of small modular trolleys that can roll into place and be locked, where I've got the workspace, workspace, workspace. Now let's say Patty's got an operation over here on the backside of this, and we wanted to, because the largest equipment that you guys have just turned this one very large workspace into a U-shaped cell. Everybody understands that. But what they might understand less is that having one big behemoth of a workstation is an inverted U-shaped cell. For Patty to do anything, he's got to triple his distance. It's the opposite of taking 0 steps inside of a U-shaped cell, 0 steps with the space, versus to do anything, I'm tripling my motion waste. And the transportation waste is caused by the shape of the trolley. So the cool thing is, this is one operation, 1 meter. This could be its own rolling like that, separate. And whenever you need to, because you guys have a long linear line, the way this could look is you have your long line, your product is moving this direction, but the operations with the small modular things, you could bump up and have a shape like that for your workstations and operations. Let's say there's 3 operations. You could have a U shape then go like this. It depends on what you want to do. The part, as you're moving down, can go through or make a U.
So you would have
modularly.
You'd have the workbench off the side of the line?
Exactly. So instead of having 2 big areas that take 2 big amounts of space that are forcing Patty to walk around all ways, now he solved that by making them back to back, so he moves much less. But why have him move at all? So this, we'll just simulate this. If this were the workstation, it's slowly moving down. I just have, simulate it like this. Let's say this operation's here. I'd have a dedicated work cell right on the line. Of course, whatever you do first is over there. The part moves down the line, and then you reconfigure. You can come this way. You can come off the line this way instead. Part's moving down, pull, right? Value add, boom. But the reason I'm saying this, the first thing we did is make really big things on wheels. What we found is we need really small modular things. The best thing we ever saw was about 90 high, or 3 feet, you guys are at 3 feet, 1 meter wide, 1 meter deep. That's just what we found. Workstations everywhere. And so on the spot, any point in the production line, you can manipulate and do that. Same thing with your cut and sew over there, or your upholstery. They have long, wide benches like this, and they have a lot of lateral walking. That's okay if your part is big. Your parts over there aren't that big, they're kind of small. So you can just have this move, or you can have the big table still, but now you've created on the spot a U-shaped cell wherever you needed it. So now maybe you have a gluing operation or a staple operation, and then you have another operation over here. They can do one-piece flow in one station.
It's all on around you. You're like here, here, here. Do 3 things without,
Because you guys don't have a size that's huge. The biggest size you have 2. Patty deals with it there, and your laser cutter deals with it there. And the rolls. After that point, everything you guys do is small until it gets back over to tile. So having a lot of little tables on the spot. Now we would do crazy stuff. Here's a U-shaped cell, and we've got people working in here, but then it needs another operation with a different person.
He's saying build everything in a wee small trolleys and you can configure it all the time, whereas we're kind of fixed with two big tables. If we wanted to move that now, it's hard because it's a big massive. Yeah.
Where I'm working down the line, and then it needs to actually go over there because of a different process. Or, okay, every 6 needs that, but if we don't have that right there, then so it'd be this on wheels. So you pull that. So I'm doing the operation, turn, hit it with the product, it goes down the line. And so you guys are you're doing this creates long linear space.
Where would you see that being over here?
Yeah. This stuff? So yeah, that kind of thing would be on this line. So instead of having a long linear line, because you're doing whip and you're batching, Patty doesn't have to walk around, batch it and move it, batch it and move it. I know this isn't configured right now, but instead, if you do the cut, you just have the small operations.
Yeah.
But long linear is that. Anytime you have a big open rectangle or a big square, it's the inverse of a U-shaped cell.
Yeah.
It's tripling any distance, but you don't have a part requirement that actually requires that. Your order size, your piece size isn't that big.
So, Paddy, what do you think, Paddy? Do Paddy and Paul think? I want to keep them on board.
That's just an example.
Yeah.
And it may not work here in this cell.
What do you think? Like the new layout, like a U-shaped cell, or like having wee cells off the main line, or?
Yeah, it'd be good. So that is the very start of this improvement, and
Right.
very.
So these 2 big tables could be 8 small tables.
Yep.
Because each one's an operation.
Yep.
The only reason I'm saying, anytime we see a cart this big, because our piece orders were like 5,000 pieces, and then we may have a high variety. The next order might be something we never see again for 6 months. And then, but because you guys you already have your jigs, you already made it modular. Hey, this type of operation is done in this cell. You reconfigure the cell at any point in time, right? Lean's about changing your environment to suit the problem. Instead of working around the problem, change your environment to suit the problem. And so having a lot of modular stuff that can dodge in and out, usually anything long and linear is, it's creating a lot of excess transportation waste. Patty, what do you think? That's right. Paul.
What do you think? Is in if you're creating a lot of processes coming off that line, the motion for Paddy coming out and going into every one of them sections. I know for bottlenecks, you can add extra people there all the time, but for Paddy, it's going to be here the majority of the time himself coming out, and then you see that there's a lot of excess motion.
Yes, it can be, but that motion is created because you guys have this big long cuticle. If you had a whole bunch of little tables, instead of it being a big long thing. So the first thing we did is we took a bunch of forklifts. We had the conveyor belt style and people standing to the left and the right. We just kind of moved those out of the way. And so instead of having a long line like this, we ended up having where that product would kind of snake its way around, and maybe you have 1 or 2 people here, maybe you don't. Sometimes we had W cells where you had a fishbone effect, where you had 2 types of product that had to join together, and then they joined together, and then they went down this cell, and then we might have some other thing for different operations, or usually it's a different part feeding the line. So the long linear distance isn't there. It's all really compact. So we would move our machines, every single thing we reconfigure because we had high variation. But you guys do the same process. I mean, if we moved a machine, it was because we're using this punch press and it's set up with this die, and we use this a third of the day. But 2/3 of the day, we don't use it. So now this order's coming through, we're just gonna pop it off the wheels, scoot it out of the way, move the small punch press in, move the riveting machine in, move the hydraulic press in, and you'd have 2 or 3 people in a cell. Now, I know Patty is just the one guy, but even if right now you have Patty doing this in 2 big cells. So for Patty, the parts are here. For Patty to do anything, Patty's got to keep walking around this. It's arranged pretty well that he's kind of got this going on, but even if that were just a whole bunch of little cells, and he could be in here, because this is the largest or nearly the largest part size you guys have to interact with. So it's really about how do you picking the parts as a kit, How does he not ever touch it? How does he not let it stop until it's on that little trolley? Making a whole bunch of 1 meter by ½ meter by about 1 meter tall, or 90, whatever you guys want, standardized throughout the factory. Anyone at any workstation can grab it and create a U-shaped cell or an L-shaped cell or a W-shaped, whatever you guys need, to then quickly manipulate anything.
Might be a good idea to watch the work. If we watch Paddy doing it for a while.
Yeah.
Because there's D-nuts going, there's assembly, there's maybe a wee bit more than, there's a lot to it, isn't there?
Yeah, let's do it.
Watch a couple of chairs being done.
We're thinking the next stage in this process, the way we have it at the minute, across.
Yep.
The peanut machine that's up behind, but in this area here, and then off here. So whenever it comes across here, it's peanutted before it goes on this line.
Got it.
It's going to be, I think, your process.
Just turning.
You just have to look. So this could be ideally your different processes.
Right.
5 or 6 processes down that line. It's right behind you.
A similar thing for the T-nut. This is an idea. It's probably the wrong idea, for sure. You guys know the right thing. So you have the T-nut machine, and yeah,
2 U's.
2 small U's. So instead of, I'm trying to eliminate Paddy having to do this, even though it doesn't seem like a big deal. If he can just,
I get you now, yeah.
boom.
Yeah.
The same process can be used, well, pretty much everywhere, but another big opportunity would be over there behind the other folks. You'll find weird things that don't work, and then you iterate. The 2 big tables, almost like this, right? The first drawing was basically boom, and you do the operations, turn it back. That's pretty good. But this is doing if you can have this do the walking for you, it'd be nicer to come off, work, and then let's go down to the next tile.
Same idea as what we were thinking on the U's instead of straight.
Anything that's straight, yeah, same idea. I'm just trying to introduce the concept of a whole bunch of small modular cells.
Yeah. We'll watch a few now, will we?
Yeah, let's do it.
I like the idea of watching a couple.
Yeah. And it's gonna turn out poorly, but let's just say it. All right, so we'll snag these up to here. Let's say you're going here. I think these, really, this would be here, and this machine would be here. But we're just doing it as best as we can right now. You have this right here. It's too bad we can't. Can we scooch this? No, there's air on it, isn't there? We're clearly too crammed into here, but let's just go with it for fun. Can you try to come in here, grab, rivet, sand, done. The main thing is, and this could be another U-shaped cell. Yes, it's going to be batched to here, right? If you could sand too.
Left and right.
And it moves. The goal is to get the parts through the line as fast as possible, not the person.
So we make 10 different products of chair here. This is a different product than the last one.
So he'll swap this out, right?
It will, yes.
I was over processing there too. Oh, so it's done.
That's that done.
Oh, okay.
The arms then go to another jig on the back.
On the back side.
Yes. So because it's always different products every single time.
So you would just push. So so the arm jig, you would just bring the arm jig to here so he doesn't have to move.
Yes. Yep.
You see, like let's say it was like the previous chair. Does that feel, I know you kind of felt crowded in, but the concept is there.
Have we got another one on the line? What do we have on Milano? We can do a Sorrento too if you want. It's a similar chair. It'll give you more of a time-wise.
Probably pause it while we're...
That machine for that process, pull down the next one.
Yeah. But for his processes, he's got a bunch of jigs. And so with the jigs being back to back, you're making Paddy walk around everything.
Yes.
It's the opposite of the U-shaped cell. But if you just invert it, you say, I'm going to have a bunch of little workstations, and it'll come in. When I'm doing the left one, maybe I do the left one here, the right one here. I'm Paddy. Boom, make this arm, turn, boom, 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 make this arm. All of that slides to here. Assembly, it goes away. With the assembly cells, You're right. For the pick and pack, maybe it's something different. I like your idea of the T-net being before this.
So that would be a whole process on its own. Once the machine's finished cutting, the person then putting the stuff away could also clean on it.
We started with it being over. Now we're just moving it further and further up the line.
Yeah.
So they can batch, and then over here, once you pick it up, it just keeps going.
So it's a matter of then really put it together.
Yeah.
There's a lot of different ways, but I definitely do that.
Because we were going to have 3 tables off the end here rather than these racks. So it's all an experiment, and whatever works best. Yeah.
Then I had to get a lot more, whereas now I can kit all the chairs at the end of the day. So.
And are you kidding on a trolley? You have your trolley here, and you're just kidding? Yeah. Are you guys batching by kit?
You know what I mean? So there's a lot of lifting.
Are you guys nesting by kit?
Nope.
Because if you nested by kit, you can just say, oh, it's a Serrano. Boom, boom. But if it's on the trolley, and the trolley is what feeds your line, because they already nutted it, then there's no roller, or maybe there is a roller, whatever it is.
So why we didn't nest per kit on the machine is because we had a lot of waste.
Material waste, yeah.
So that's why we thought a picking line.
Right.
Because we can nest an extra couple of, say, a wing or an arm,
Buffer,
and then put it on here, and then pick off this. We can get our nest a
This
lot.
can just keep going. Cycle
lot
time
better.
doesn't impact the rest of production.
Yes.
Next
I
time.
always want to like start. Once I cut 2 chairs, so that's my first 2 chairs. Straight away down.
Because you have the wood and the plastic then to go on, it's getting the 2 of them cut.
It's because of the machine cycle time. That's
Yes.
why. No, that's all really good info. Now, if you had the small modular thing, for some materials, maybe your high volume ones, you had the T-nutter. Imagine these racks aren't here. If you guys want to come around here, you could come off the machine, T-nut right here, and just start some pre-assembly, or just T-nut and kit, and then it can just start snaking around. Anything long and linear is forcing the human to walk.
Yes.
You can, but if you're on the rollers, that's fantastic. Make the cell at the roller, because then you get the best of both worlds. You have the long and linear, and you have the patty not having to walk a bunch.
All this stuff now, if you have the cleanup machine sitting here, no matter lifting it, cleanup on the rack.
Then you only touch it once.
To one side.
Yeah.
Because,
Yes,
you know,
right.
That would
Great
be
idea.
that'd be brilliant, because we have thought we have a big U-shaped cell now off here onto the line across, and we're trying to work in the middle, but we're just wondering, where do we arrange the T-nut machine? Where do we arrange the workspace?
I think Patty knows.
Yeah.
That's why you guys have the best ideas. And I don't know the timing on it, but the best way, I'm wrong on the time. What we would experiment with and attempt to do is if we could nest our chair, and the production cell, including the T-nut, was right here. And maybe you batch the plastic, because you're not doing anything with plastic. You batch the plastic somewhere else, or some other time frame.
Yeah.
If this comes back and is a full cell, and he's not touching it to put it on the rack, and touching it to pull it onto the Kirakuri, and then touching it to assemble, and then putting it on the trolley to go over there. If he's pulling it from here, T-nutting it and doing assembly, then it's bypassing. Remember, it's from the time the material is cut until the time the material in the customer's hands. They don't care about working hours, they care about actual hours.
Yes.
And so that's what we would try to.
That is the goal. It's that one piece flow to get it to the customer as fast as possible.
Yeah.
And I think the picking line for us, that's what we were thinking on, the picking line, because if you had a breakdown for say,
You have buffer
you have
time.
a small buffer there. We have a day that we can get it back up and running again.
you need somebody out kitting these because so like I'm not going to be kitting it, you know, unless you're going to kit it there and then. So I need somebody else out or give me a hand to kit it. These flow here,
Right.
you know, until I go ahead and then kit it this evening.
Right.
So, you know, I can't do one piece flow.
I think it makes the most sense because this is a very expensive machine and it's a long cycle time.
Yeah.
So if you nest however you nest, have the riveting machine here,
Yeah.
then from there, you can ignore all of that.
Yeah.
You can pick to the line,
Yeah.
pick to the, like with the rollers or whatever. If you want to pick yourself so you have a small batch of 2 or 3 to work on or 4, or if someone else is picking to feed you,
Yeah.
the nut process, I think it should be right here, like you said. I think it's a fantastic idea.
Already keynote it and then kit it. That will speed up a lot then.
Well, it eliminates 3 handlings
Let's cut it down.
because it was a small batch because you picked it up to put it on here, you picked it up to put it on there, you picked it up from there to bring it over. but then you were batching the T-nutting. So if you're already here and you're already holding it, just T-nut it. And then that eliminates 4. So your 5 goes to 2.
Yeah.
Immediately. I think that's a genius idea, Patty.
We've already cut it down by less than half already, the process.
From 5 to 2?
Yep.
Well, then you throw the U-shaped cell at it. That's just such a powerful tool. That's why we had 150, 200 meter by meter tall tables, the whole factory on wheels. And anytime somebody needed something, they would just create a line. And then they'd be crazy shapes. It'd be like because they could. And then as they were doing, and then all the power and water was above. Power, water, and lights were above. And so they could make the shape whatever the product needed. And then they would just all come together. There's a lot of fish bones. And then sometimes you have like 3 fish bones of C's and S's flow into one section, but then there's a big C. But after they learn the tool, they really start using it.
That is a brilliant idea as well, because we do 10 different types of product there, and maybe 5 or 6 processes in each one of them. And it's similar to our welding area, where we're pulling a welding jig in, pushing it out, bringing the next one in. So whenever you're doing one chair, you could have that small table pulled in, do that process out of the way, very quick. Next process on, do that one.
And a lot of what you guys do is very similar. You only have, what, 5 products?
We have 10 different chairs.
What do you do 80% of the time?
80%.
So I'd optimize for Serrano 2, and then I push the waste to your lowest volume ones. And then you have the Serrano 2, and what's the next most? Milano. Okay. So I optimize for Serrano 2, and then Milano.
And just work your way.
And then you work your way to the not the lazier one, the low volume one. Yeah. Make it super efficient with SMED. SMED is those 4 stations, those 2 tables should be 4 or 8 small tables. So Patty can have, like this, if this is a routing operation, but let's say this was a sanding operation.
Yep.
I have a small thing here, rivet, sand, begin the assembly or whatever it may be. If you can bring the rivet and sanding, then you're only touching it once. It's a slower to batch to there, but then you've eliminated, it's basically ready for assembly.
Yep.
You've taken your 5 to 1.
So we made the trolley size to hold 2 chairs on top. So every time there's 2 chairs, Patty has to deliver.
Then you did once, but then there's too much space over there. Cool.
Robots that generally lots of minutes, 3 minutes for it to get there, then back. So you're going to need to have a specific.
Well, the thing is, if it takes, say, 20 minutes for us to do our tag time, that has 20 minutes to get down and back up again. Yes.
Can I take the trolleys and we'll go to one more spot and test?
Yep.
Okay, let's go. Patty, thank you. Thank you. What do you think? All right. Generally, it's just this big. Let's say there's multiple operations. You have some cutting. Sometimes you have to do some stapling. So now without moving, he still has 1 meter, 1 meter, and 1 meter of space. These tables might be a little undersized because those chairs could be big. If the part is moving, the person doesn't have to move, he keeps stepping to the rights to get those because he needs the space and he needs the stuff. But if you have the stuff on this cart, the product could be right here, and you can just grab or twist.
Yep.
Now it's an L shape or a U shape. It's a significantly different. Or if you need a lot of operations, which usually these kinds of operations don't, you can have another table here. We made some lines that were like, it flows to here, and then that person takes it and it goes on another line. And then this final assembly was exactly where it still is, where it pops on.
That fresh eyes again.
So you're given this space, but it's for one product. Maximize, keep one big table for when you need it. But if you have the space, then you didn't have to modify the table at all. Just use the additional thinking. If those are always the same product, I mean, most guys have very similar things at different stations because they're upholstering different stuff.
Yes.
We had all our air and hoses above us. They could reconfigure to fit whatever the line is. A lot of it fishbone together. We'd have attachments for our arm pullers, like what you guys invented there, where it would bolt into the big table. So I'd upholster, flip it right here, keep working. Now I'm not walking because you just added more steps to that.
Yes.
It's about lots of small modular things, not a big thing. But the first thing we always defaulted to, because we made 18 or 20 tables that were twice this size. On wheels, we thought we were doing so good with lean. Look how cool we are. And then we started seeing batching, and we wondered why. And we said, no batching. So we forced them not to batch, and then they didn't like it because the linear table was having people have to go sideways and reach. And if you notice, a lot of them are bunched up by their tools and stuff anyways. They're trying to do it as close as they can.
So because we're doing the 3 upholsterers doing the one chair,
Yeah.
they each take turns at arm, back, foot, plate, baseboard, and that.
If we're cross-training.
So what you're thinking is then, if you had one area for arms, one area for back, and the people just move around. So if you have these jigs are fixed,
Yeah.
if them jigs had to be here, well, would have to move around each person.
I haven't watched the process enough to know, but
Yeah.
it's more giving them the option to modify their environment.
Yeah.
I'm not saying to do one thing or another. I'm saying this is a tool that they can use to figure out. Even if it's something as simple as this, if we just pulled this empty table next to Sean and it wasn't in the way, and he had some stuff on here, just, oh, I don't like that because of these reasons, or it's good, but it's not stable. Maybe it's about testing. Your factory doesn't use a lot of L-shaped or U-shaped cells.
Yeah.
A lot of other companies do. When we went to County Battery or whatever the repair facility is, everything they were doing was like 5 cells, and everybody internalized it at a high level. But I don't know. Anytime I see anything long and linear, I ask, does the part size require it?
Yeah.
If the part size doesn't require it, you've created transportation waste for no reason.
Yeah.
And if you specialize for the Milano, and the Sorrento 2, and it makes everybody's life easier for 80% of the time, and then occasionally, with the big order that you rarely get, there's an extra motion and waste. You've made it up by this being a lot low effort.
I definitely see that, even over
Well, this is
the
3
table
meters.
size. Yep.
This is 3 meters, but he's only using the 1 meter.
Yes.
But you're making him walk to get stuff over here and stuff over there. For in case we have the one part that's this big. I know. Shot by one that work.
Yeah.
Or maybe you need to for 2 or 3, maybe one big table. Oh yeah. If you had one big table and a bunch of little cells, this is where we're talking about the weird shapes. People would get it. The part, because it's big, you don't want it lifting. Would start here, doing assembly, and it pops off to the U on that side because someone else needs to do a different operation. So now it's slowly moving towards final assembly. But the big thing is a whole bunch of little tables like this. I mean, this trolley is almost identical to what we're talking about.
Yep.
Maybe you do need the big one. Or maybe the big thing would be like, what if you want to just go talk to them? I'm sorry, I'm creating complete chaos in your organization. We're not saying to do this, we're saying this as a tool or a concept. If this station always uses that stuff, you're doing a lot of linear walking, but you're only using this 1 meter of space, almost always, except for the very few occasions. So if that stuff were on, and this were here, right? Let's just pretend this were here. Now we're here. Instead of stepping, if it was just like this, then there's 0 stepping that he's doing. Then maybe these can live over here. I suspect these are only over here because you don't want to put them over here. Or this is a product you rarely use. If you put them over here, now this becomes too crazy.
Yeah.
But if this were right here, pull it, snip. Now a small L shape is taken care of. This is 2 meters, right? Well, this is 2 meters. Here's a meter, but I'm not taking a step. That's all we're saying. Maybe you two need to work together. So you have one on your side. Right? Maybe you're fishboning it.
Yeah.
You guys are coming to the center, and then someone's standing over there, and it goes, boom, right to that. Lots of little small tables like this. So at any point in time, on any machine, any long linear line, you can turn it into a small L shape or C shape. It was Chris, same thing. Because there's multiple trolleys, right? Because Chris, you come in here. If you were standing, because these are the same 3 workstations, basically.
Yep.
So if you're standing here, Chris just uses the 1 meter in the center, but he has to keep walking to get the stuff. Maybe the stuff lives on this. Maybe the stuff lives on that, and then one day gets knocked over, and we'll say, oh, we don't like it, it's unstable. You know, we really need this here. So you have this holstered in front of you, and so then you gotta start tweaking it in. But yeah, the goal is to have a whole bunch of little cells that are modular.
Do you struggle for, when we were setting these up, we did struggle for flow, and it's because of the size of the tables.
It's because, yes, I hate long linear anything. Everything should be a cell.
1, 2, 3, straight on to the next.
Check this out, Can we grab, oh here, let's, can we grab these tables and we're gonna just move over there? Let's say you had a sturdy square table, right? Because you need a bigger shape. I know it's kind of weird, but imagine you have a sturdy square and you just pick it to here or whatever it is, and then it's just a U shape, and then it's completed. Then that moves over here, right? Because now you can have specialized ones. Maybe arms are here and the backs are going this way. Maybe 2 of you do the left arm. I think you guys are each doing 1-piece flow, where each of you are doing 1 full chair. That's genius. That's brilliant. That's probably preferred because your output is 3, because you're probably balancing against some other capacity, right? Is final assembly pretty quick? So that's what. So you have 3 dudes here because that's fast. You guys need 3 people. That's right. Perfect. You guys already get that. So basically, I would use a whole bunch of small linear things. We found we accidentally created massive transportation burden. People think transportation waste is like, oh, there's these great things. It's this big. No. I'm not gonna lie. Why am I doing this? You accidentally create a motion waste. For why? Oh, well, our biggest chair is this. Let's punish everyone for this one product. Then it's like, well, what do we do 80% of the time? Let's do 80% of the time, and when we do that, 20% of that product, we'll just make a specialized cell for that. Yeah. So, well, so here. Well, you guys could all be. So you guys are okay. It's long linear rows. Let's say, in theory, wave a magic wand. If we just took this today, right now, and we just rotated it, and this was just left here. Honestly, if you did this, boom, that's 2 cells. Your one big table became 2 small tables. It's probably a little narrow for that, but in theory, if you had one here, you're picking it. Now your backs are open. There's a big U-shaped cell. The feed line's popping out to feed whatever needs to be fed at the time. You guys are in small L shapes or U shapes. Most people only need an L shape ever. Yeah. A U shape is like, I got 18 operations to do. Because then you have 3 meters, right? This is 2 meters of space. You have 3 meters with a U shape without a step. But everyone's only using the 1 meter in front of them. But you're making everybody walk. And it's because of the shape of the table. Now, but now the shape of the table, maybe it's fine. Maybe you need one big table. The big table is designed to work with the little tables so it can be modular. Yeah. What we started doing is we said, well, we already built these tables. It took us 4 months to do. And we spent all this money. What do we do? I said, cut them in half. Weld wheels in the center. Or whatever. We did some crazy stuff. Oh, this thing. I didn't even see this. If this were the table, because you're not even using the half in the back. No. Here, we'll just simulate this. You have the modular big tables like this, and then you got 2 like this that float. So at any point in time, you've got whatever shape you need to build. Maybe you guys figure out one-piece flow, 3 guys doing one-piece flow, or 3 guys working on one chair. This flows to here, flows to you, and then you guys do this. What we've also found is that this is a slower operation because it's a back, but that's a faster operation because it's the arms. So we have, on this side, we have 2 inverted Cs. Imagine this is mirrored on that side. And then 1 person over there doing the fast operation. It's all experimentation. I don't know the answer. You guys know the answer. I'm just showing you the tool. Almost nowhere you're not using any U-shaped cells. That line right there, it's a long linear line. You don't use the whole thing for the final assembly where Kyle's at, but it's not really a linear thing. He's kind of standing in one spot because it's by color, right? Well, if you popped these 2 to the edge instead of it being in front of him, because I think he's still doing some moving to get different things for different chair types. If those things lived on this or this type of thing, this could be completely wrong. This probably is wrong. This is just showing you modularity. Yeah. Do you guys have any specialized machines? Maybe there's a jig. Okay, you have your arm jigs. I'd have those arm jigs on a trolley that's heavy, like your old welding jigs. And maybe you're going to do it and you're going to say, it's on wheels, it's not good. So you don't have this kind of a one. They have a wheel that when you step on it, the wheels come down. Yep. And when you left off it, the table sits on the ground. So now it's stable, but it's still modular. So now you're just twisting it and moving it and doing all kind of stuff. Yep. Do you guys have anything like this in the factory?
Our Sorrento table is something similar. It's not U-shaped. We work around the outside of it.
Okay, so when you work around the outside of it, it's an inverse U-shape. You're forcing everyone to work around it. It's the opposite. Yeah. You've tripled or quadrupled everyone's waste. This is probably the closest place. Yeah. But it's still just it's an L shape, so it's easy. Mm-hmm. I bet people like working in there.
That's good. That's
they do like it?
It's good. Quick. Do your work, stay under the belt.
So take the learning lesson. So I would just do this. I would have we tested this with like 4 trolleys and then we built 200. I know we engaged in overproduction. We built 200. Our factory was larger. When we built the 200, all of them were used up immediately. Everyone wanted them in their area. Yeah. And some people would be like, well, sometimes we have this product that's really long. And so they would just run a table out because we had the big table for this one product that was really long. And so we just ran a table out. And then that one product rested here while they were working on the other end. And they could still be small and nimble and precise. So why won't this work? What are we missing?
Small tables make sense. And this is a couple of areas. And as you say, it probably work in every area.
It's usually every area. Yeah. But we made this mistake. I'm not saying that this is a mistake. It's not a mistake. Yeah. We made a mistake of making 8 or 10 massive tables Because before that, it was even worse. And then we're like, oh, look how good this is. Everything's here now. We're like, wait a second, we're only using this little bit of space. But the human arm's a half meter. But then it's a meter, right? A half meter there, a half meter back. And so now it's 1 step plus a half meter, plus grabbing it, plus coming back, plus the step back. And now we've just taken like a 0-step operation to adding like 50 or 60 meters to our product that we're forcing our customer to wait for. And then we're tired when we go home. And so people like that cell. Yeah. Anyone else? Is there any other cell people like? Anything like I really like doing this job in the factory? Is that the only one? Foam scrubber. The foam? Oh, spraying? That's the only one everyone likes? It's because the only one that no one's doing.
And then the only one with kind of small tables is the welding. So they pull a jig on, they do their work, they push it out, they bring the next one on, do the
and
work.
You guys, and the smart thing about that is that the whole well, it used to be the table turn, now the top of the table turns.
Yep.
And so if you have the big one, I saw the big Sereno there, I saw him do it where it turns. If I'm standing in one place and the whole thing turns, that's fine.
Yeah.
But for the most part, that's not the way it's being used. There's a big thing and I can walk around the outside. It's convenient to use on the outside, but I'm introducing the motion waste.
Yeah.
Invert it, make a bunch of small L's that are modular. Any product comes along, you're probably going to be drilling or putting a rivet or putting into a staple gun. Any project that comes along, you're probably going to be cutting, adding Velcro. So make it modular for the small part that you do. What you might find is that your 3 dudes here, maybe 2 dudes can keep up with that now because you're taking away that space. Someone can hijunku float over to help somebody else that's slower. It's the table shape. The table shape is what caused all the problems, but people don't realize it. A big shape, right.
But then we were using big tables.
Yeah. I would just turn and I would tweak the tables.
Yep.
Yeah. Because even if let's say that table didn't exist, and this table were back to back, you had 3 U's, and they were these exact tables, no difference, but you guys just had this small table here. You're going to reduce your transportation waste and then your motion waste by just tons of motion waste. You're kind of in like a big backwards U. People can still walk through the center, but you guys still have the modularity and then it just spits out onto that line. I don't know the answer. You guys know the answer. I'm saying here's a tool you can use. It's almost the same as saying like here you can use Velcro and here you can use pens down. Here you can use these tables to make a cell. And also usually anytime there's a big table, it's created a bunch of unintended side effects that nobody realized before. I would do a whole bunch of tables like this with specialized card tables like that because these are more modular.
Yeah.
What our answer to this was this is still quite unruly. We'll just put 2 tables like this in the end. And so everything was standardized across the factory. So now we've got, anyone could build any shape they needed to. I mean, we had V shapes, we had whatever the guys needed, they made it so they didn't have to move. And they figured it out really quickly. Yeah. The whole day.
Or stretching of the table.
Yeah. Because you're just a meter. You know why? You're stretching because you have to step and you'd rather just stretch because it's easier than stepping. But if this were just here, I mean, I would just use the trolleys. I told Ryan maybe make like 4 per, this place could use 4, Patty's could use 4. You'll learn real quick and you can float them around and change the label. This is now this department's.
Yeah, makes sense. Definitely. You'll be thinking already.
You're going to try it and you'll be like, oh, this works, but I don't like this. Those should be on a thing here. So, you'll figure out all that stuff,
Yeah.
There's more you guys aren't, most places you're not using modular. You're doing linear. Linear is almost always have unintended consequences. Cool. Well, sorry for taking your time, guys. I interrupted everybody.
Tells you you're doing arms. This is what you're doing at this station.
Yeah.
This is the frame.
Yeah.
And then I just turned it around.
That's, perfect.
Worked that side. Clutch bolts are here. Tools are there. Whatever you needed was at each section.
Incredible. Only downside. Well, actually, no, because this is the part side. This is appropriate because the part size demands it.
Yep.
Over there, the part size doesn't demand it. That's the only reason I said that.
Yes.
The other thing is if you wanted to change this, it's more difficult. Versus if these were tables, modular. But this is great. Say, okay, imagine we scooted this over here. You see this big table?
Yep.
If you had modular trolleys, we're just going to do it. Boom. And then you use it and you say, I actually want to be over there a little bit. So you just twist it. Oh, now it's not even a U shape. Now, modular.
Yeah.
Just like this, you have boom. The person's in the center. You're doing here. You just offload some of the tools to here.
Yep.
Same thing with a line over there. Was a big long table. Maybe you need to because the jig. But now the workstation suddenly is an L shape or a U shape.
Yes.
Or maybe there's certain tools, certain of these that can live on this.
They could be on there, yeah.
If it's stable, whatever, this is going to create problems, and you fix those problems.
Yep, that's it. Yep.
I like this. That's cool.
It's been several months since we were in Ireland, and Ryan and his team have been working super hard. They've come up with tons of improvements, better stuff than I would have ever thought of, and they're just an incredible team. So guys, the next section is how far they've come and improved. They took their whip down from 8 to, I believe it's now 3, maybe less now that time has passed, but this is the update as of now, and you can go check out more of Ryan's videos that show this off. Enjoy.
Okay, so I'm back here again, so that's Chris here. So the plan, just so you know, the plan is to connect this, have this conveyor going the full way through, right through here, right through here, right through here, and then, sorry, I'm going to pull that table in this way and connect the upholstery lane onto this table and then go straight down the middle here. But once that line comes straight through, all these workbenches will be pulled in tighter, and I'm going to make them all smaller like you said as well. We're going to actually cut the tables because they're far too big, and it just allows us to do this kind of thing. Hi Mommy, I also want to show you this. If you could show Mr. Amazawa and Mr. Umamura. So we've changed the layout of the cutting. The cutting used to be away down here. So now the order comes in here. Then we cut. And then we're building a new sewing room. So before the sewing room was in here, remember? Remember it's in here, but it's too far away. So we've built a brand new room. And now the material is going to go through here directly into the sewing room. So we've built this new room. So cutting through here, sewing, and it will go through this door and then connect onto here again. So this is a brand new room. This is all done since Japan, our trip a few weeks ago, after seeing Mifune and how well everything is laid out. So the sewing box is going to come through here. Then we're going to do a big roundabout like a carousel, and all the machines are going to be in a circle. So now everybody has to get up every time and walk to their box and get the material and walk back, but no more walking. It'll all be a big round carousel, and they sit and they just bring the box around. I'll show you when we get this built, but I just wanted to show you this new room. So we're taking this all away. This is going to be, we need more offices anyway, so this is going to be offices, and this will be the new sewing room. So we're connecting the work better. Hello Hugh, so this is the slot coming in through the wall here, and then the carousel will be here. So we're thinking the person who's sitting here will just pull we'll feed the line, so the box will be coming in through here, so all they have to do is push it onto the carousel. Then the person who's sitting on this side will take it off the carousel and push it onto the outfeed conveyor. So here Hugh, it's coming in this slot here, carousel, and then around, and it's going to come right through the middle of this door here and then connect onto this one that's already here. Well, it's actually going to be higher, so it'll be hovering over the top, so we're not mixing up the sewed parts with the foam. But we could maybe upholster here, but it still needs foamed, which is done here. Then upholstery is there. It is going to tighten in, but yeah, that's where we're at. Hi Hugh, so we've got this all painted now. So the next bit we've done today is this track from here, so from the slot to here. So we're just going to get the roller track attached to it now, and I'll send you another video. So this will probably hold like 1, 2, maybe 3, about 3. So there'll be a potential for a work in progress of 3, which is really good compared to how we're doing it now. So yeah, getting on well. But I just thought I'd show you this new setup here in the cutting area. So we've put up these flaps here now to keep the draft out from the door. We've moved the cutting area up to here, and now the sewing room is where the cutting area is to be. So all the boxes get cut here, go down this conveyor and through this chute into the sewing room. The foam's still coming in there as normal. So cutting is around here. These green boxes are going back to the start here with gravity and falling through there. Then I'll just go into the sewing room here. So we're going to come through that hatch in the wall into this roundabout here. So this just moves, so the machines stay in place, and then the people just move this here, move the box around to them, sew their stuff, put it back in the box, and then put it up this conveyor. So this runs up here, right up around the corner. Here, over this bridge, and down the other side. So the whole thing is connected now from cutting right through onto the roundabout, up over here, over this bridge, just stuck in here, right down here. So now we've split this, so sewing boxes are on the top, foam is there, and then the return boxes go back here. So we've got it to here, and then the next stage now we're going to take this on over. So it's a good job.
By the way, guys, one-piece flow is a big deal. We have a community with free resources and free tools, and it is linked below in the description, where you can ask other business owners how they're using it. We also have beginner courses, how to use the free tools to help supercharge their business. If you like this kind of stuff, make sure you check out other videos on my channel. Ask questions in the comments, ask questions on the free resource area. If you have any questions, the content we create is directly a result of the people asking us questions and interacting. And so we are building this for you, the community who need the help, and we really appreciate it. I would not have a channel if it weren't for you, and the content is driven by the questions that are being asked. Guys, hope you enjoy this. We'll see you next time. Thanks so much for sticking around to watch. Please help us by watching this next video.